Okay, now let's make the sixth exercise from this series. For this one, we're going to work with the tangent. Again, let's start. Y of x equals tan of x. Then y of x equals the tangent of 2x, and then y of x equals tan of x over 2. And again, we're going to do exactly the same as we did in the previous video. First, let's make a little bit, sorry. Let's start with this. And for the tangent, I'm going to make something in here. Now, the first thing you have to know about the tangents, and let me just add one curiosity in here. I don't know if everybody knows about it. What is a tangent? Well, let's go to our trigonometric circumference. This circumference has radius equals 1. And this is a sine, okay? This is the cosine, and the maximum, it is just 1 and 1. I'm going to put in here. This is minus 1 and again minus 1. So the sine, for instance, let's suppose we just pick an angle like this. Let's say alpha. If we just go down here, we are going to see the cosine of alpha. If we just take like this, we are going to get the sine of alpha. What about the tangent? Well, the tangent is very interesting. It is this one. It is interesting why. It is a parallel axis to the y-axis, and this is a tangent. Okay? And the interesting is this. Well, for this alpha, this is a cosine, this is a sine, and what about the tangent? Well, you just continue. This is going to be the tangent. This value, this height, is going to be the tangent of alpha. And that is why when we just increase this, that is why the tangent of 0 it's 0, because we are down here. And what happens when alpha, it is 90 degrees? It's going to be infinite, right? Because take a look at this angle in here. It goes like this. I don't know. Yeah, okay, maybe like this. So you see, it goes, increasing. So far, we are something like this. This height in here, okay, this height, it is going to be the tangent of this angle. But when you have alpha equals 90 degrees, this line here, okay, that defines the angle, it is going to be basically parallel to the tangent axis, like this. And because they are parallel, they will never meet. That is why when we have the tangent, okay, the tangent of 90 degrees, we don't have this one, okay? It doesn't exist, or we might say it is infinite, okay? And that is why we say the limits of the tangent when it goes close to pi over 2 or 9 degrees, it is infinite, because it will never meet this line in here. Okay, that's a curiosity. And that is why, because we are approaching, oh, and when it's, okay, when you have the tangent of 90, it is positive infinity. And what about, let's suppose, when we have the tangent of 91 degrees, it's going to be how much? Okay, let's say the tangent of 90, because I'm starting to get inside the calculus. Okay, I must be careful not to get inside there, because it opens a lot of doors. Let me just state this. It states this: the tangent of 9 degrees, it's infinity. Okay, and when you go to this side in here, like tangent of 91, okay, a little bit of the 90, it is going to negative infinity, because let's suppose that we just take this angle in here, another one, okay, and now we are measuring this angle in here. Look, from here to here. Okay, this is the angle now that we are measuring, this angle in here. How can you know the tangent of this angle? Well, we just have to prolong, and this is going to be the tangent from here to here. Let's suppose that this is beta, so this is the tangent of beta. Okay, but agree that if this line, it is very close to 9 degrees, but on this side in here, okay, very close to 90 but bigger than 90, okay, we are going to minus infinity. And that is what happens when you are close to 9 degrees. So this is very important. So when we are close to 90 degrees, or when we are close to pi over 2, and the same goes when we are close to minus pi over 2. This is in 90 degrees. This is very dangerous. Why is it so very dangerous? I'm not going to use the green one because my green is not good. So let's use this one. When we are close to 9 degrees, that function goes to infinity. Okay? Remember the asymptote? It is this one. This is the asymptote. And we have to use it when we are discussing the tangents, because the values, they go to infinity. You see, look, it goes something like this. It's very close, up there, when we are very close to 9 degrees, but still a little bit less than 90, okay? And then we are very close, and then goes, and the same goes in here. It never touches, okay, the asymptote. It never touches. We can write this asymptote. And here is another one. And this is a chart of the tangent. Okay? And like I said, there is not much point about changing the amplitude. Well, if we just increase, let's suppose y of x, it is 2 tangent of x. The chart is going to be a little bit like this. Okay? And we are just stretching up, okay? Just like a line, and do this. Okay? This curve is going to be into here. And let's suppose y of x, it is tangent of x divided by 2. It's just half. We're just taking this curve and bringing it down here. I'm not going into details because it is supposed to be a very simple video. And okay, one other thing that we have to account for, it is the period. This is very important. The period, it is just pi, right? Okay. It is just pi. Why? Let's analyze from here. I'm going to make probably another video just discussing this. I think it's better. For now, let's leave it like this, okay? After this video, I'm going to post another one that is going to deal just about this portion here, because I'll have to make this drawing as big as this. It's much easier. Now, this is the tangent chart. Let's go to this one now. What are we going to do? If this is multiplied by 2, let's first start in here. If we're multiplying, this is going to be the period change, right? Change. Why change? Because it's not 1. And what is happening? Multiply by 2, our period is going to be divided by 2. Okay, meaning we are taking this chart and doing this. Let's make a little bit like this. We're doing this with this chart. The asymptotes, they are going to come closer to the y-axis. And talking about this is x, this is y. Not that it's going to change much, but let's make it things complete. Okay, what is the first thing you have to do in here? Of course, our x, y. Again, remember, I'm going always to do at this distance. It's not in scale at all the charts, okay? The idea is to be able to see things. Remember, everything that is related to the period, it is going to be divided by 2. What is everything that it is related to the period? It is the x-axis. Okay, everything is in here. It is going to be divided by 2. Everything, all those points, all those lengths, okay, these widths, okay, everything that it is related to the y-axis, it is going to be divided by 2. Since here is pi over 2, this is going to be pi over 4. Why? Half of this one. This is going to be negative pi over 4. Everything is going to be divided by 2. The period will also have to be pi over 2. And if you just add pi over 4 with pi over 4, we just get pi over 2. Okay? And now let's make our asymptotes. Not this one. Probably this one or this one. Doesn't matter. Okay. Always draw your asymptotes. And now just make the drawing. Right there it comes with infinity. It goes like this and then reverse. Again, it doesn't touch, okay? Of course mine touches because I'm just doing freehand. And this one, what is this period? It must be half of that. Everything must be half. And it is, okay? It is just pi over 2. This is going to be the chart for this. And what about the last one? Also very straightforward. Oops, before that, let's just analyze what is going on in here. We are just dividing the 2, okay? So this half, okay? This is going to change the period to what? Well, if we just have, oops, if we just have divided by 2, our period, it is going to be multiplied by 2. Okay, not very difficult. Again, let's do in here. This is x, this is y. again, let's, oh yeah, let's draw right now the asymptote. Like this. Let's make some symmetry. I then complete a little bit more to the left. They are symmetric, relating to the y-axis. Let's complete a little bit more. Okay. Now, this part and this. Let's see. We have to start from this. We can't start from this, okay? We can, but it's going to be a little bit different. Let's start with this one, because it's just one, okay? The number here is just one. What is going to happen between this original one, okay, and this one? The period now, it is multiplied by 2. So everything on the x-axis is going to be multiplied by 2. If this is pi, therefore pi over 2, I'm sorry, then this is going to be just pi and minus pi. Okay? It doesn't take much to see. I'm going to do it already now. That this period, it is going to be 2 pi as previously imagined. Why? Pi, if we double, we get 2 pi. Now, oh, let me just finish this one. And again, it goes all the way from infinity. And right at this portion, it changes the shape, okay? Because in this way, I would say that the first derivative, it is positive, okay? And now we just invert, okay? I'm not going to get into details in this. I mean, actually this is the second derivative, it is always positive, and the second derivative, it is always negative, and they call this an inflection point, because in here we're always trying to bend the curve up, okay, like a parabola in here, but in here it is the opposite, can you see? And this is an inflection point, but this is calculus. This is not the purpose of this video. Just to conclude, okay, if we just, let's suppose that we start in here, from here to here. What is going on? From 2x we go to x over 2. We are dividing by 4, aren't we? We start with 2x and end with x over 2. We have to divide. If we divide this by 4, we get here. Meaning that if we are dividing by 4, the x, the period, it is going to be multiplied by 4. It is the inverse. Pi over 2 times 4, 2 pi. Pi over 4 times 4, pi. Minus pi over 4 times 4, minus pi. Because from this one to this one, the ratio, it is division by 4. In here, in the x, this translates into a multiplication on the y-axis by 4. Okay, and so from here to here, plus multiplication by 4, and from here to here, multiplication by 2. But I prefer to start from this one. Okay, that's it for the chart. We did not change anything about the phase. Okay, if we change the phase, what's going to happen? We're just taking this entire chart and move a little bit in here. If we just have plus something, we're going to take this one to the left. If we have minus something, like 2x minus 2, we are just bringing this one up here. And whenever we add or subtract a phase in here, that it is pi, or a multiple of pi, this is not going to change. Okay? Because whenever we add or subtract, when you have a phase shift, that it is the size, okay, that is a multiple of the period, nothing changes. Okay, then that's it for this one.